Okay, then now we are moving to linear regression, and we are going to study how to analyze or estimate linear regression models. Okay, okay, okay. Here we go. Of course, I'm going to upload this lecture note. Okay. Okay. Please download this note before you watching this video. Okay. Okay. Here is the linear regression model. So y is dependent as always. X is the matrix of exogenous variables or independent covariates. And beta is their coefficient. And E is error terms, of course, right? So we suppose we have capital T observations. Okay, capital T observations. Oh, let me put yeah, this would be better. Okay, so we have capital T observations. Okay, so of course X is capital T by K matrix and beta is K by 1 vector. Okay, and then of course the OLS estimate is X prime X inverse times X prime Y, right? And then its variance is sigma square times X prime X inverse. Okay, this is what we learned from the frequentist approach or just econometrics 1 course. Okay, and then let me express linear model. Let me express this linear model from Bayesian point of view. Okay. Again, as always, model is a data generating process. The data means the dependent variable. So model describes how the dependent variable is generated. Okay. Okay. So according to this linear regression model, this is how y is generated. Okay. First of all, sigma square is generated from a distribution, and we assume that sigma square is generated from this inverse gamma distribution. Inverse gamma distribution is defined only on positive area. Okay. So and I'm going to explain the details about this distribution later. Okay. So for now, just take it that take that sigma square is generated from a just positive distribution. Okay, and the inverse gamma is just sort of the convention. Okay, so again, the first of all, sigma square is generated from this distribution. Okay, randomly determined, and sigma square is determined from this distribution. Then subsequently beta is generated from this normal distribution, and its mean is beta 0, and the variance is sigma square times b0. Okay, so beta is K by 1 vector, so then beta 0 is of course K by 1 vector, and here b0 is K by K vector, K by K matrix, because this must be variance and covariance matrix, and the uncertainty of the beta is proportional to the size of the errors, which is sigma square. So sigma square is what? The size of error or the size of noise. If noise is large, then uncertainty of the coefficients must be large too. Right? So given beta, now beta is generated from this normal distribution, then given beta and sigma square, y is determined by this normal distribution, or y is also randomly generated from this normal distribution. Okay, again, it is really important to understand, or really important to note that y and parameters beta and sigma squares are random variable a priori. Okay, a priori. Okay, so this is my belief. Okay, or this is my theory, learned from macro or the microeconomics. Okay, this is my theory from my intuition or the theory or the experience that y must have been generated by this sort of the process. Okay, again, parameters are randomly determined from these distributions, and exogenous variable x is literally given exogenously, and we have no idea how these independent variables are given or generated or determined. We have no idea. The what we know is that anyway x is given. Anyway is given. Once x is given, then finally y is determined by this normal distribution. So it means that y should be it means that x should be given before y is determined, right? So this is the model, okay? So the x must be exogenous and y must be endogenous, okay? And then you should agree that y is exogenous and the x is exogenous and y is endogenous. And if you don't agree with that, then that means this model is not good, or this model is not convincing to you. Okay. So for example, x must be weather. Okay. X must be weather, and y is the response such that you carry umbrella or not. Okay. So then we agree that weather is exogenous, and then carrying or not carrying the umbrella must be endogenous, right? It should be determined by the weather, right? But if the weather is dependent and umbrella is on this right hand side, then this is not a good model, right? Because you know this, right? Endogenous variables should be endogenous, and exogenous variables must be exogenous, okay? Based on your theory or intuition or experience, right? Like this, right? So this is our prior belief about parameters and dependent variables. So this is model, and then this is also the description of joint distribution of parameters and dependent variables. So this is joint distribution, okay? Joint distribution of the parameters and dependent variables, okay? So this is model, and model is given before you observe the data, okay? And after you observe the data, after you observe data, now you can derive the conditional distribution of the parameters given y, right? A priori y was also random variable. Now you have some observations about y. Now you have some information about y. Then also what we know is that y and the parameters are very highly related or correlated. So that means y must have some information about the parameters, right? So then we can make much better guess, or you can get much better estimates of the parameters using the observations. Okay, compare to the case we don't have the observations. We must have the better or the more accurate estimates of the parameters using the information contained in these observations, right? And please look at here. If you look at here, so the y given beta and sigma square, and you see no beta 0, no beta 0, no b 0, alpha 0, delta 0 here. Again, here is alpha 0, delta 0, beta 0, and b 0. These are here, right? But also you can hear that sigma square follows this inverse schema, right? I don't like this. Sigma square given alpha 0 and delta 0, right? I don't put this conditioning, right? Why? Because we call these parameters hyperparameters. So hyperparameters are not random variable. So these parameters are determinants. Okay? That means these parameters are constant, or these parameters are chosen by researchers, or they must be chosen by yourself, right? So there is no uncertainty about these hyperparameters. So these hyperparameters describe your prior belief about sigma square or beta. So delta alpha 0, delta 0, b 0, beta 0, and b 0 are used to just specify your prior belief or prior information before you observe the data, right? So then you know exactly what they are. So that's why these parameters are not random variable. And then to distinguish them from these sigma square and beta, we call them hyperparameters. And then beta and sigma square are just model parameters. Okay, and x also we assume that x is just purely exogenous, and x is not random variable either. Okay, that's why there is no conditioning. There is no conditioning hyperparameters and exogenous variables. Okay, so this is Bayesian linear regression model. Okay, and also this is how you understand linear regression model. Okay, so whenever you judge or whenever you criticize or whenever you understand a linear model, you should look at them in terms of data generating process. So then also the data generating process is convincing or sensible from your intuition or theories from microeconomics and macroeconomics, or just intuition. Okay, and if there's anything you don't think is sensible or not convincing enough, then there must be some problem, and then you can improve it or criticize it. Okay, so yeah, this is a Bayesian linear regression model.